Hello everybody and welcome to today's webinar. We're going to be looking today at solidifying your future with Autodesk Fusion. Yes, no longer Autodesk Fusion 360, we are now in Autodesk Fusion. So today I'm going to be taking a look at some of the fundamental building blocks of Fusion as a whole, as a product. So the features we're going to be looking at today are going to be features that are available to you out of the box from within the design environment. So we are going to be looking at, we're not going to be looking at any extension functionality, we're just going to be looking at out of the box functionality within Fusion 360. Before I forget, my name is Cameron McKenzie, as I've gone straight into the product, but yeah, I'm an applications engineer here at Man Machine, and yeah, we're going to be taking a look at the product today. So I will quickly switch over to this side of the room. And we're going to be looking at the different functionalities that are available directly out of the box within the product. So really, when we're looking at the future of manufacturing, we're wanting to understand a product that is able to take us into the future, right? So we want to be able to, within our product, be able to have something that is parametric, it's adaptable to various changes within the manufacturing workspace, whether we will have a single component that needs very minor changes to it, and therefore other instances, other elements of the design need to make adjustments. So we do have parametric modeling inside of Fusion. We also want something that is capable of collaboration. We want something that we've got the ability to look at from anywhere in the world at any time. As long as we've got access to a computer, we want to be able to view the design files that we're working on. So within Fusion, we have Fusion Team, which allows that capability. Fusion is also cloud-based, so we've got the ability to access our designs from anywhere, wherever we are. If I have a quick look within the browser, so at the moment I'm just on the main Fusion interface over here, but if I quickly go into my browser over here, we can see that we've got our Fusion team within a browser. So within this view, I've got the ability to view the project that I'm currently working on and any relevant information regarding that, who created the project, when it was created, and so on. Against each of the individual components, individual parts, we've got the ability to then go and view those at a top level, look at the item itself. We get a thumbnail against the component, we've got the ability to view from there. If it's within an assembly, we've got the ability to see where it's used, and if it is an assembly, what it uses. So I can see all of the individual components that are used inside of an assembly. A little bit later on, we're going to be looking at configurations. So we've got the ability to see the various configurations of a part of a component inside of the team view. Again, all viewable within a browser. I can go and view individual instances of each of those as well, or just view the top level assembly from within here. Now, apologies, our internet is a little bit slow this morning or this afternoon now. But it will be loading that hopefully in a few seconds. If not, I'll just switch to another component very quickly. Switch over to the leg base. Hopefully that's a little bit quicker to load up. If I go over to the view of it, you can see it will just do, it'll just quickly go and generate a view based on the latest version of the component, whereby we've got a full 3D view of the object that we can make use of. We can then change the visibility, change the background, change various ways of having a look at the component, including creating section views, doing quick dimensions against the component. Again, all web-based from within here. So you don't have to have the full installation of Fusion to be able to view this type of information. As long as you've got a license, as long as you're associated to a team, you've got access to be able to view this information. If we jump back inside of Fusion, from a parametric perspective, we've got the ability to very quickly make changes to our components. If I jump back to that leg base that we saw on the mobile section, if I rotate and adjust this model around over here, apologies, it's a little glitchy there. I can go into the parameters and actually have a look at the values that are making up this component. From within this setup, I've got the ability very quickly to go and make adjustments to the number of legs that I potentially want to have inside of this component. I could go and change the diameter. I can change the leg length if I rather want this to be a little longer. So at the moment it's about 400 mil. If I want to bump this up to about 500, I can go and change the values in here and the leg lengths adjust. So rather than having to go and redesign our components every single time, we've got a package that allows us to use parameters and be able to very quickly make minor changes to the component without, again, having to reinvent everything along the way. And these parameters then allow us to also go in and start to make equations. So if we wanted to have certain values related to others, whether it be multiplying it by X amount, dividing it by another amount, we've got the ability to start building up these parameters from within the interface, whether they be parameters that exist inside of the model or whether they be user created parameters that are used for reference and calculations later on down the line. Another option we might want to look at when it comes to future-proofing our design workflow is how intelligent is the environment that we're working inside of? How much does it help us in the design process? So if we do have a component, much in the same way as we got over here, where we've gone in and with our own potential engineering knowledge and design experience, we've gone in and decided that the leg needs to look a certain way. It needs to connect from the central component where the seat itself comes in and connects to the legs, and then gets connected to the base where the wheel will sit in. We get an understanding of how that should look potentially, and we then try to model that. But what would happen if we decided that we wanted to explore a few extra options? Now, I'm sure most of you have seen or heard of the generated design or studies that we can do generative design inside of Fusion. But fairly recently, there's also been the introduction of automated modeling inside of Fusion. So we can take an existing component once more, either a model that we've designed already or something completely from scratch. We could work in an assembly environment, we could work in a part environment, and be able to start to reimagine the way our objects are connected to each other. So we can quite simply go in a model like this one, and begin to start making some geometry. So we know that we want to ensure the void that sits inside of this model over here remains where it is. So I could come in and create geometry directly from the inside of this, matching the diameter of the inside of that hole. So I know that that's about 75 millimeters. We can make it give or take from within there. I could then go and create a bit of a cavity so that I know that this is the area in which I want to enforce a no-go zone, basically, an area that I don't want any geometry to go into. So I'll make this at about 40 mil deep, and rather than it joining, I'm just going to create it as a new body from within there. And then I'll essentially do the same thing on the opposite side. So where the wheel will come in and be attached, I want to create another little bit of geometry down there. So I'll do the same thing on the opposite side over here. And just quickly create a quick bit of geometry. Got to pick up the center point. 20 mil should be fine. And I'll extrude that out. I'll go about 20 mil on this one. Also creating it as a new body. So taking an existing design, now again, this doesn't have to be an existing design, this can be completely from scratch. We can go in and then turn off the visibility of any of the other components that might exist inside of this. So in this case, I've got body 2 over here, which was the original component, and I now have 2 voids on opposite sides that I want to be able to join together. So using the automated modeling, I can go in and begin to get some inspiration of what possible connections we can grab between those two. So I've just gone and said I want two faces that I want to connect. There's nothing currently I want to avoid. I don't mind which direction that comes in, but we could add those in if we wanted to. I'm going to let that go and generate in the background now. But essentially what this is going to do is we're going to go and calculate the distances then between those two faces, the heights, the height differential between them as well, and begin to start creating geometry between those two faces. We should start to see, as this starts generating these, we've got two different categories to the types of shapes that it creates. We've got a smooth connection, which is going to try and blend the surfaces into each other as neatly as possible. And then we've got a sharper connection. It was a sharp connection, whereby it takes the entire surface, gives it a finite thickness, so an exact thickness all the way around the component, and then begins to join the geometry into each other from there. But against each of these designs, we've got the ability to change some inputs against them as well. So we get 6 results in this case. If I scroll down in the correct location, you can see we've got 3 smooth transitions, so from one shape into the other, and then we've got 3 sharper connections with the unified thickness all the way around those surfaces. And as soon as I peel back the thickness against each of these, it'll give me a variation in thickness against each of those components. Now, Fusion's not, as part of this process, going to calculate what the ideal strength is for that particular component based on a material or anything like that. This is up to us to decide. This is just there for inspiration to get to the right shape and size, and something that looks quite aesthetically pleasing throughout the process. But you can imagine trying to do that. You can see in my history tree over here already how many steps it's taken me to get to that particular point. Whereas using automated modeling, we've essentially got 2 separate surfaces, told them to connect to each other, and we've got a result that looks something like this. As soon as I'm happy with a design or happy with a style, I might go and take this one over here, reduce the value, reduce the thickness a little bit, and hit OK on there. This then gets created as a feature for us. Let me jump back into Fusion. That gets then created as a feature for us, whereby we've got the ability to do full organic modeling using T-Spline modeling. So if any of you are used to any T-Spline modeling, especially inside of Fusion, it's going to be the exact same environment, same options that are available to us inside of this. This essentially just converts the entire surface into individual surfaces that have unique splines connecting them together. And that means that we can actually go in and make further modifications to any of the componentry along here. So using the edit form, I can go and take an entire ring of surfaces over here, of edges, and I can begin to either scale those up or down. I could move them back and forth. That is scaling them. I can go and scale to the side as well and move it up or down or to the sides, making it larger or smaller. This particular one, because of the way it's been designed, has a line of symmetry as well, so anything we do to the one side will be done to the other. If I go and select that node over there and make any adjustments to it, you can see how it's automatically adjusting it on the opposite side over there. So we can make something that looks a little bit more, I suppose, organic looking, a little bit more rib-like or spine-like if we wanted to for some or other reason. But we've got full flexibility on the surface modeling side of things. So this isn't as much parametric modeling as it is more surface modeling that we've got the ability to make use of. And whether we then again use this design as a starting point for an overall fully parametric component, as I say, we can make any adjustments we want to the positioning of individual surfaces, edges, or nodes within the T-Spline model itself. I'm going to cancel out of here because I don't actually want to make those changes to the particular component. But once I'm happy with this, I've saved those changes anyway, it doesn't matter. Once I've made the changes that I want to, particularly to this one, I could then go in and force a circular pattern once more around here. So if I go into my create, I've got the ability to go in and finish this off with a nice circular pattern, grabbing that body that I used from before, grabbing an axis that I want to rotate everything around, and saying that I want however many instances of this around the central point. And this has now gone and given me a very different looking, but still really powerful way of going in and creating these the same leg base as a whole. So that's automated modeling inside of Fusion. Another option we have as well, if I go back to my leg base component over here, much better looking one, much more manufacturable, I guess, from this particular one. But we've got the ability with one of the newly released features again inside of Fusion is the ability to create configurations inside of Fusion. So taking a little step further from the parameters, whereby we can quickly go in and say how many instances we want in a pattern like this, what the thickness needs to be, what the diameter potentially of the wheels need to be, or the wheel position, so the leg length and so on, is we can go in and start to create multiple different configurations of a particular design. So using the configuration table, I can come in and set up multiple different sizes of a particular component. So in this case, I've got 3 different instances at different sizes. So I've got a 600mm and an 800mm sized one with different leg configurations for each of those. Now, one thing you might notice is if I have a look at this from the top over here, with a 3-legged base, we've got a particular taper angle for the leg itself, which makes sense when it's supporting a certain amount of load. We're dividing the overall load into 3 different legs. But when it does come into 5, that same taper angle and the thickness of the component might need to be able to adjust. You're dividing the load a little bit more by extra 2 legs, and therefore you don't need as much of a thickness. And also that would then mean that those legs are then hitting into each other. So we've got the ability during a table configuration like this one to be able to go and set the leg taper angle at this point. I can come in and adjust that from a 5 to a 3 if I wanted to. And you can see how we've got, using parameters and configurations, the ability to make adjustments to each of those values. And we can have a different setup based on the different configurations we want. So we've got the 3-wheel, we've got the 5-wheel, and we've got a 6-wheel configuration available to us here. These configurations can pick up on any dependable parameter inside of Fusion. So if we wanted to, we could go in and grab other aspects from the design itself. So any feature that exists inside of our feature tree down at the bottom, whether it be a fillet, whether it be a shell, whether it be a revolve, any individual feature that exists inside of our process, we can decide whether we want it or not. And if we do want it, what aspects of it do we want to adjust per different configuration. We can also go against the component itself and then begin to establish, well, certain configurations might need a particular material while others need a different material, or even down to the appearance of particular components as we go through. If we take this a step further and have a look at an assembly level, we can then begin to take individual parts and create, especially configured parts, and bring them into an assembly and choose which configuration of a part we want in which configuration of an assembly, and start to nest our assemblies in this regard. So if I have a look at this assembly, for instance, I might have a few different configurations of the assembly itself. So I've got the 3, 5, and 6 wheel assemblies over here, showing the different wheel configurations against each of those. But I might also have a different material or different appearance against these assemblies. So in this case, I've got a chair over here with a bit of a red leather texture to it. And at my 6-wheel configuration, again, this can be different. I'll go back to the gray or the darker one. If I go for the 6-wheel configuration at 800 diameter, then I can have potentially a different material or a different appearance against that. And this is easily configurable, easily changeable again inside of the configurations table. So if I go and grab it over here, we've got what Fusion will call the themes. So I've got a theme inside of this this chair over here, where I can go and flip between the black, red, and tan configuration. So if I am looking at the 3-wheel 600, I can then choose which theme, which appearance I have associated to that particular component. So we can really start to structure these in any way, shape, or form, and be able to make changes to them right from the top level, and be able to bring those changes in from lower level componentry along the way. Against each of those configurations, we can then have properties against them. We can go in and give each of these different configurations not only a component name when it is set inside of our list, but also a part number and a description against each of those. We've also got the ability to come in and add other components directly from inside here, and make any other configurations once more against those. But from a top level perspective, we've got the ability to come in and switch from a configuration drop down on the side over here between the various different configurations that we've got set up inside of an assembly. And the same is the case inside of a single component file. We've got the ability to come in and make those adjustments to it. One thing you might also have noticed inside of the configurations themselves is I've got a wheel count value here that I can get to match the component itself. So for every time I'm using the 3-wheel configuration from my leg base, I'm then creating a pattern of components that are inside of the assembly to then match that. So I then have 3, 5, and 6 wheels dependent on the configuration that I'm wanting along the way. One of the other new configuration options, or sorry, not a new configuration, one of the new feature options that Fusion has released fairly recently is the ability to add in fasteners. So this can be done in an assembly level. So we've got the ability to come in and add fasteners into the assembly wherever you require. So we've got a library of standard fasteners that we can begin to start adding to our componentry. So if we did want to be able to fasten the seat to the rod down below, we've got the ability to come in and use our insert fastener option. It's going to go bring up a table of standard fasteners. Give it a few seconds just to load up. I can go and look at bolts and screws, nuts and washers, and begin to look inside of this list for any of the types that I might particularly want from within here. If I go and grab just a standard heavy hex bolt over here, for instance, I've got dimensions against each of these that I can come in and change. So I can go and grab my nominal size. I've got a length that I can grab. I've got a material, a finish, part number, description, and so on. But we've also got automatic placement as well. So you'll notice that as soon as I hover over a hole, it's automatically going to go and calculate the size that I require for that particular one. And in that case, any circular geometry, so even if you don't have a hole that is in the correct position, but you've got circular geometry referencing the center point of where a hole should be, we've got the ability to go in and grab the center point of that as well. And you can see there it's automatically picked up that requires an M36. If I go through to these holes over here, because those holes were created as a pattern originally, they were created as a single feature, Fusion's going to automatically realize that those are likely going to want to have the same bolted connection between them. So if I zoom in a little bit closer over here, I can go in and place those in over there. I can still on top of this adjust the sizing of that if I wanted to, and the length against that if I needed to as well. And as soon as I'm happy with that, I can hit create and continue, or just OK, and that will then go and place those bolts into my assembly within a fastener subfolder. So very quickly got the ability to go and populate our files with a lot more information as we go through the design process. The other area that is really important, again, for the future of manufacturing, solidifying our future, is the ability to then grab outputs from this. So it's all good and well having a really nice looking model over here, which is fully parametric and fully adjustable and configured and so on, and if we don't have a means of manufacturing this, there's very little point to it. So we've got the drawing environments inside of Fusion, and we've got manufacturing environments within Fusion itself. So directly from inside of a single interface, I've got the ability to go switching to the manufacturing environment where I can go and create machining toolpaths. I've got the ability to go in and create nesting and fabrication models, even down to 3D printing and that. So we've got those as an output that's available to us from inside here. We've also got the ability to create simulation studies against our components to make sure that they are able to withstand the loads that we want to put them into, and be able to match the criteria or the use cases that we're going to be putting our models through. And we will cover these ones in a future video coming up in the next month or so. But where we do want to focus on this morning, or this afternoon, is the drawing environment. So in the last update or so of Fusion, there's been a huge release that's come out that we're really excited about, and that is automatic drawings. Now, yes, it's not going to go and create a fully configured drawing that's going to be, I suppose, perfect out of the box 100% of the time. There's still going to be some configuration that's required, but the amount of time that it will save you from a basic drawing perspective is going to be a huge amount of time. So to activate this is pretty much the same process as you've been working if you are working in Fusion. If you haven't been working in Fusion before, it's just a case of going in from the same design that you're working in, going and saying you want to create a drawing from the current design. This is now going to allow us to have this new automatic option, where before we would go in and manually create a drawing from the view itself. There's still the option to go and create it manually if you wanted to, but we've now got this automatic option available to us from here. With our configurations, we've still got the ability to create a drawing from a particular configuration. So any of the configurations that we've created inside of the model, we can go and grab from within there. And then when the drawing itself that we're grabbing, we can either go and create one directly from scratch, or if we do have a template, we can go in and grab our drawing template and be able to make a automated drawing from an existing template. Another really cool part of this is the sheet creation structure. So we could either go and create it just at the first level, so it's going to take the first level of the assembly that we're looking at, or we could go a little bit further and say, actually, I want you to go and create a drawing from all of the levels that exist inside of this assembly. And if there are any external components, which I have a few of, I want to include them in the model, rather in the drawing itself. So hitting OK on there now, it's going to go off and calculate this for a few seconds. Now, depending on how intricate your design is, how many components you have, and so on, this might take a little longer for some instances. But if we have a look at this in a few moments, it should go in and create a job in the background against this one. This one's now gone and completed it for me, or it's about to complete it for me. You can see it goes and calculates this off in the cloud. So it sends off that job for me into the cloud. And it's going to enable us to then very quickly create drawing views of the component itself. So again, this will take a little longer depending on how many components we have inside of this, but you can see it fairly quickly considering we had a fair number of objects and componentry in there. So that has gone and finished now, so I'll just hit open on there, and this will take a few seconds just to go. Apologies again, I'm just going from one device to the other. There we go. So you can see very quickly gone in and created a cover page which has the assembly on the top level, or automatically gone in and populated a bill of materials in the top right, or a parts list in the top right. If I go over to the second sheet, you can see it's gone and taken the assembly and given me some important dimensions against the assembly itself. So it's given me the bottom to the seat height in this particular instance, and it's gone and given me an estimated width of the component itself. If I go over to the next sheet, it's now gone and given me a view of one of the components, the wheel of the assembly itself. It's then also gone in and dimensioned the base as well as the seat itself. And you can see each of those have got their own the detailing inside of the title block. They've gone and added in some information about the bolts that I added in there as well, giving me a really nice leader in there, showing me how many of the bolts I've added inside of this assembly as well. So really quickly gone in and been able to grab all of this information directly from the assembly model itself. Now, as I mentioned, this isn't necessarily a fully completed drawing of the assembly. We might want to make some tweaks to that, and it is still flexible in the way that we can go in and make these tweaks. So at any point in time in my dimensions panel, I've still got the ability to go in and add normal dimensions, or I can go in and alter the automatic dimensions or the auto dimensioning. You'll see against each of these drawing sheets, we've got 3 or 4 different types, sometimes 5 different types of dimensions sets available to us. So this is broken down then into symmetric with baseline dimensions, symmetric dimensions, baseline dimensions, chain dimensions, and then overall dimensions. So depending on the type of dimensioning you're wanting to do against this particular view, we've got the ability to go in and grab those from within. Within each of these different styles, we've got the ability to choose where the datum location is against each of these. So whether it is a manual datum point that all of the dimensions are coming from, especially for our baseline dimensions, or whether it's top left, top right, bottom left, bottom right. For our symmetric ones, they will generally just be the symmetric in terms of the center of the component itself. As we can see from the center line over here, everything else is being dimensioned from there. For our chain dimensions, we've then also got the ability to chain those from a particular point in the model. What we can also do against every single one of these options is choose the density, the number of dimensions that it's picking up for each view. So by default, this has gone and given me all of the dimensions in there. In this case, though, 6 out of 9. So it will tell me how many dimensions are available for this particular view, and of those, how many it's currently showing. So I can come in and use the slider towards the bottom over here to increase or decrease the number of dimensions that it is picking up as part of this process. I can bring that all the way down to a single dimension, which is going to give me from the center to the top of the part, and then slowly work my way up and add as many of these in as I want to along the way. So I've got this option available to me on each of these drawing sheets. As soon as I'm happy again with those, I can hit OK, and I can use the normal tools from here to be able to then go and move this view around if I wanted to. I can reposition it from here if I wanted to. I could even go and rotate the view around if I wanted, and choose the orientation, choose a different orientation of the view, choose a different style and so on that we would be used to if you have worked inside of Fusion's drawing environment before. Another really handy tool that they've added fairly recently, I think it's almost a year now, is the automated center marks and center lines from within the drawing environment. So again, standard base functionality within Fusion. There are no extensions required for any of this functionality. We can go in and very quickly go and grab the center marks of a particular view. So in this case, I might want to go and grab the center marks of this component over here. And we can pick that up based on the feature that was used to create that particular center. So if I used a hole tool to create a center, it would show up in here. In this case, I haven't. If I've gone in and done a round cut, it would pick that up. Again, I haven't in this case. If I've gone and created a round extrusion, however, it will then go and pick up that center mark from within there. And same for center line. So whether we're using a hole tool, a round extrusion, or a round cut, if I go and grab round extrusion, you can see that it adds the center line along that extrusion that I created towards the top of the component. Now again, nothing's stopping you from going in and entering all of these items in individually, manually from within the design environment. I could go in and delete any one of these dimensions if I don't want them there anymore. And I could very easily go in and use the normal dimensioning tool to go in and dimension any features that I want to on top of that. So nothing is stopping me once more from adding these dimensions in and annotating my drawing further. I could even go in and still place in any projected views against my base views that were just created as part of the automated drawing process, and still go in and dimension these further or annotate these further. So really the automated side of things is just going to be there as an assistant during the process. There might be some times where it's just taking out the mundane tasks that you have to create for certain drawings. You know that certain components need a quick overall dimension, and rather than having to go and click multiple times to add these dimensions in, we've got the ability to use the automated drawing, get a overall design or an overall dimension, and pop that straight in from within there. Another option, I think lastly one, is the ability we have now to configure the settings from within our drawing environment. So the Fusion drawing environment has come on a long way over the last year and a half or so, whereby we've got a lot more settings, a lot more customization options available to us when it comes to the setup of our drawings. So as with most other programs, most other applications, we've got the ability to create a custom title block. As you can see over here, we've got our man and machine one. So these can come in and bring in any fields, any properties that you need to from the model and place them inside of the drawing sheet itself. But we've also got the ability to start going all the way down into the fine-tuning of how all of our detailing is managed. So if I go into the document settings over here, we can go in and grab and define, first of all, what font is used across the entire drawing, just to get that uniformity from within there. And if we are wanting to set the text heights, we've got the ability to choose between a small, medium, or large text height, which would then go across the entire border. Or across the entire drawing, whereby we've got a main small, a medium, and a large height that everything else comes in and adjusts from there. So anything that is set to small will be at 1.8, anything medium 2.5, 3.5 for large. If I go to the largest configuration of that, we've got large text coming in at 7 mil, medium at 5, and small at 3.5. But we can come in and set this to custom as well, so we can come in and choose the heights against any large, medium, or small bit of text that sits inside of our drawing. We can also come in and start to fine-tune the line widths from within here. So are we using medium density line widths? Are we using thinner line widths, or again custom ones from within? And we can come in and choose the sizes that we use inside of this. All the way down to the annotation options. When we are adding in dimensions, do we want to have a certain color associated to them? So we can come in and pick any color that we might want to against a particular dimension or against dimensions as a whole. I can go in and grab this yellowish color over here, hit OK, and all of my dimensions change to that. I probably don't want that particular color for this particular one. But we've got the ability to go in and fine-tune all of the levels of this, including labels, notes, sketches themselves. When it comes to the views, we can have different values, different colors for different types of geometry. So I've got a slightly darker color on any of my outer lines and a slightly lighter color on any hidden lines, and that just to kind of emphasize those outer edges a bit more from within the design workspace. All the way down to hatching. There's been a lot more available to us when it comes to hatching for any section views and so on. Down to tables, we can configure all of the table setup from within there. And they've now also introduced with this recent update the ability to choose what happens with our automated models, automated drawings rather. So when these automated drawings come in using a template file or using a particular document setting, we can come in and fine tune exactly what needs to show up, when it needs to show up, and how that particular annotation object does need to show from within there. So we've got a lot of customization that is now available, which really brings a lot more functionality, a lot more detail into the drawing environment, which I know a lot of customers, existing Fusion customers, and prospective Fusion customers have been wanting for a little while now, and we've now got a fully functioning drawing environment available to us. So with that, that's pretty much what we wanted to go through and show today. Again, we wanted to look at solidifying the future of our manufacturing workflow. So we're looking at what will be the future, what does that entail, and do our products then match up to that? And for what I can see within Fusion, we've got a really powerful product, all cloud-based, all ready for the next phase in the manufacturing workflow. So with that, thank you all for your time. If you do want to have any more information about anything we've shown today, please feel free to get in contact with us, either with your account manager or directly to the sales team as a whole. Other than that, thank you very much for your time, and I will see you again soon. Goodbye.